Let's take a look at a radioactive decay model. Carbon-14 is an element used, or it's an isotope of an element that's used for radioactive dating. Every 100 years you lose about 1.2% of the amount you had. So if that's every 100 years, let's take time steps of 1 century each, 100 years each. It's reasonable to track the amount that's present in some sample in micrograms. So let's start with 10 micrograms, and because we're losing radioactive material now, our growth rate is negative. So let's switch over to Excel. We'll copy the same sheet that we've been doing and call it radioactive decay. And our growth rate per year, we could still call it growth rate per year, but it's negative now. Let's show a little more precision there. And time step number, so this is in centuries, and this is kind of carbon-14 in micrograms. And we said let's start with 10. So we still have the same formula, growth rate per year times current amount. You could say that over there, and we'll just say that negative growth rate means it's decaying. So let's look at our graph. It seems like, oh, r squared equals 1 again. Once again, we are excellent data analysts. So that's your classic radioactive decay model. One thing we can ask about is called the half-life. How long does it take to reduce from what it was to half of what it was, which would be about 5 here. So it's kind of hard to see that on the scale here. It's definitely less than 200, probably less than 100. We can scroll down here. So starting with 10, when do we get to 5? So somewhere around here. So that's 57 or 58 centuries. So that's 5,700 years or 5,800 years is the half-life. So you'll end up with half as much as you had at the beginning. What if we trace that out another 57 or 58 years? We're going from 5 down to 2.5, which is just about double the 57 or 58, and that's another half-life, and now we're down to a quarter of what we started with. We could get down to 1.25, which would be an eighth after 3 half-lives, and so forth. So if we go way out here, we've gone past lots and lots of half-lives, and we have a lot less than we started with. Carbon-14 is only good for dating things up to the few tens of thousands of years, because after that it decays too much. To date things that go back farther in time than that, you need other radioactive elements that don't decay as quickly.